This course provides an overview and understanding of ergonomics. You will learn about musculoskeletal disorders, risk factors, controls, and aspects of an ergonomics program. It's important for you to understand how the body mechanics of a task can affect the potential for injury. What is ergonomics? Simply put, ergonomics is the science of fitting jobs to people. Ergonomics uses knowledge of physical abilities, limitations, and human characteristics that apply to the job design to minimize the stress on the body and to limit the possibility of injuries. Ergonomic design is the process of considering the tasks, equipment, and environment for a specific job and to provide efficient use of worker capabilities while ensuring that the job demands do not exceed those capabilities. Proper use of ergonomic principles and processes can improve efficiency, increase production capability, reduce worker injury, lower workers' comp cost, and reduce absenteeism. When a task exceeds the physical limits of a worker, injury will occur. These injuries are called musculoskeletal disorders, which results in injury or illness to soft body tissue such as muscles, nerves, tendons, ligaments, joints, cartilage, or spinal discs. Musculoskeletal disorders include strains and sprains, soreness or pain, carpal tunnel syndrome, or connective tissue disorders. Musculoskeletal disorders are medical conditions which develop gradually over a period of time and do not typically result from a single instantaneous event. However, we should still be concerned about how a task could cause a single event injury. Musculoskeletal disorders are caused by repetitive activities such as bending, climbing, crawling, reaching, twisting, and overexertion. Designing tasks so that risk factors are eliminated is an essential part of the prevention of musculoskeletal disorders. Risk factors are the elements of workstation design or employee actions that can result in musculoskeletal disorders. Risk factors can be broken down into two areas: environmental factors and activity factors. Environmental risk factors include temperature, excessive heat or cold, lighting, vibration, tool design, and noise. Activity risk factors include stressful static or awkward postures, improper gripping, improper lifting, or repetitive motion. Working in hot or cold areas can adversely affect the body. Heat affects blood circulation and can cause cramps, rashes, and general discomfort. Cold work areas also affect the body's blood circulation, causing hypothermia, loss of flexibility, distraction, and limits the dexterity of the worker. Generally, the comfortable temperature range is 68 to 74 degrees, with a humidity between 20 to 60%. Vibration is a risk factor which can cause pain to muscles, joints, internal organs, and damage to soft tissue of the hands, arms, feet, and legs. Over time, use of vibrating tools can cause serious, irreversible damage to nerves and muscles. Improper lighting is a risk factor which can create stress on the body and can result in symptoms such as headaches, muscle strains, fatigue, and eye strain. Poorly lighted areas also contribute to trip and fall hazards and poor eye-hand coordination. Tool design is a very important part of task-related design. Tools that are hard to manipulate, require excessive force to operate, are too heavy, vibrate, or are awkward to operate can cause a significant risk factor for musculoskeletal disorders. Tool design areas that should be examined include handle shape, type of actuating controls, control location, vibration, impact, force, and the amount of pressure required to operate the tool. Working in areas of high noise is another risk factor. Noise peaks above 100 decibel causes headaches, increased blood pressure, muscle tension and fatigue, as well as irritability and distraction. These factors can contribute not only to musculoskeletal disorders, but also to other types of accidents. As the force and exertion required to perform a specific task increases, the result is higher loads on the muscles, tendons, ligaments, and joints. These forces and exertion factors include weight, bulkiness, and speed at which the motion is performed. When examining the potential for musculoskeletal disorders, the worker's posture needs to be addressed. Poor or stressful posture includes prolonged standing, which can cause varicose veins, back stress, and pooling of blood in the legs, sitting without back support, which increases the lower back stress, and sitting too high with dangling legs, which can decrease circulation in the legs. Other hazardous postures include shoulders rounded forward, which can cause upper and lower back stress, as well as stress to the respiratory system. Leaning forward also causes lower back stress. Additionally, sitting with arms extended or overreaching can also cause stress to the arms and upper back muscles. The final group of posture hazards include winged elbows that stress shoulder joints and result in poor use of bicep muscles, stepping backwards, which causes loss of balance, displaced gravity, and muscle stress, locking of the knees that stresses the backs of the knees and lowers blood circulation, and bent wrist positions that weakens the grip, therefore requiring excessive force when gripping. One of the most common causes of musculoskeletal disorders is frequent and prolonged repetition. This causes muscle fatigue and stress to occur. Factors that increase repetition hazards include number of repetitions per minute, the force required, and posture while performing the task. When designing a task, be sure to look at the number of the same movements made. Muscles can tire very quickly when used over and over for the same motions, even with a minimal amount of force required. Improper gripping of material or tools can create significant stress on the hands and the wrist. Factors that may contribute to increasing gripping hazards are wrist position, the amount of hand surface area used, surface friction, vibration, and type of grip. This applies not only to holding the tool, but also moving material, using hand controls, and gripping other objects. Most back injuries are caused by attempting to lift a heavy object or using improper lifting techniques. Factors that increase lifting hazards include weight of the object, size of the object, number of times the object is lifted or moved, twisting while lifting or carrying an object, bending while lifting or carrying an object, and reaching to grasp or place an object. So far, we've discussed the hazards that can cause injury when a worker moves and exerts force to perform a task. Each employee needs to understand how to control and minimize these hazards. Engineering and administrative control methods must be considered to minimize or eliminate these hazards and are an effective part of an ergonomics program. Engineering controls are the preferred method for controlling these musculoskeletal disorder hazards. Engineering controls act on the source of the hazard and control the exposure to the hazard without relying on the employee to take self-protective action. Examples include redesign of workstations to improve posture, redesign of tools to reduce stress, lighting modifications, vibration reduction, noise reduction, use of machines to automate repetitive tasks, use of mechanical lifting devices, and changing the flow of material in the work process. Administrative controls are the processes we use to limit exposure to repetitive tasks. These include employee rotation so that workers do not use the same motions all day long, job task enlargement to give more varied actions, adjustment of work pace to reduce the number of repetitions, redesign of work methods to lower high stress and repetition, alternative tasks for workers that keep them productive but allow changes in position, force, and posture, and rest breaks to allow time for muscles to rest and recover. In order to effectively design or modify a task to reduce worker stress, we must observe the employee during the task over a period of time, gather data about the task, and look for all the hazards previously discussed. The most effective way to do this is by using checklists that allow us to examine a task in a structured manner. These checklists start with a general review and become more detailed to identify areas for improvement. As with any safety program, the Ergonomics program must be a written document that details how the program works, who is responsible for various aspects of the program, and any appropriate forms required for record keeping. The first section of the Ergonomics program details the roles of management to assign responsibilities, provide authority and resources, examine existing policies, how to take action to correct problems, and regular communication with employees. Hazard identification is the second section of the program. This section involves reporting of musculoskeletal disorder signs, symptoms, and hazards, recommendations from employees and supervisors, record review of existing safety and health records, and routine facility safety and health inspections. A good ergonomics program provides detailed information, including the requirements for employee training. The information and training section covers the following: signs and symptoms of musculoskeletal disorders, importance of early reporting, specific hazards and controls, how to recommend control methods, and protective measures. A musculoskeletal disorder management system is a necessary part of the overall ergonomics program. It outlines the methods to respond to and document injuries. Elements of this section include prompt response to reported injuries, implementation of work restrictions or other measures to allow quick recovery and return to work of injured employees, and prompt access to healthcare professionals for a medical opinion and follow-up care. For an ergonomics program to be effective, there must be a continuous evaluation process in place to ensure progress is being made and that the controls are effective. The engineering and administrative controls in place should be reviewed along with all records, employee recommendations, and the history of musculoskeletal disorders associated with a specific task. Ergonomics involves studying the process, tools, posture, force, and frequency of motion involved in a task. Proper design of the task and tools can be an effective means of reducing worker injuries and creating an environment that allows workers to be more effective and efficient in their jobs. Using critical observation and application of management tools is the key to a successful ergonomics program. For more information on the ergonomics program, contact your EHS department.